Hey everyone, Shwayam Neri from Google's Applied Engineering team. I am going to talk today about a topic that is underrated. So let's address use cases where you have a graphical user interface or a legacy application without a clear pattern to access the underlying data programmatically. Let's say that you don't have an API, or it is going to be very hard to expose a web service with the data that you want to have and the functionalities that you want to have. And on the other hand, you can access that data leveraging the graphical user interface. This could be maybe a use case where you are going to act on the data by clicking and entering some data and saving it to the database, or you want to access data in read mode. Okay, so we have this complete Pokemon Pokedex website. This is going to be our legacy GUI for this demo, and the idea is that the we are going to leverage Gemini Computer Use 2.5 Pro in order to have an API on top of this website where you just have to enter or post the name of a Pokemon, and then the API gets back to you the JSON data of that Pokemon. This is an example of the data we will be capturing: the Pokemon name, the height, weight, abilities, training, evolution chart, etc., etc. So the Gemini model is going to be clicking, manipulating the GUI, scrolling in order to gather all the data, and let's do it for Lugia, which is a legendary Pokemon. Okay, so let's go to the Swagger documentation of the API and try it out. This is our endpoint. I'm gonna put Lugia here, and I'm gonna execute it, and a page is gonna be open. So our browser agent has been used by the API, so it has delegated the task of looking for Lugia for it. So as you can see, it has been able to identify the filter text area to put Lugia, and then click on the link there. All right. Now we are into the Lugia page, and we are going to use Gemini multi-modal reasoning capabilities in order to capture the data. And given that we know already the ideal schema of the data, we know that we needed to scroll down in order to capture the depth of the data to fill all the fields that we need. All right. Um, I will show you the code later, and I will be open sourcing it to GitHub as well. So yeah. Uh, I would like to show you later in the terminal the different reasoning steps that Gemini is following to take the different actions, right? So yeah, you can see it is exploring, manipulating its complex UI, exploring different moves, right? By the way, the video is not accelerated, and as soon as the agent thinks that the task is complete and that it has all the data, it is going to mark the task as complete and close the browser and send the JSON data back to the API, which could be used into, like, this could be like a sub agent within a bigger agentic architecture. This could be part of an automated workflow, and this could really unlock really big number of use cases in the enterprise. Okay, it has marked the task as done. And here we go. We have a 200 HTTP response. And we have all the data: the type, the name of the Pokemon, its national number, height, weight, like its defense capabilities, the different generations where you could find it, the name in other languages, etc. Let's go very quickly to the code. Okay. So this is our main API. We have this route. If I go to this scraper, here you can see that we are providing this as a base URL and then providing some instructions to the LLM in order to be able to go to the base URL, do this and that, etc. Okay, so these are the schemas of the request. We have this is the Pokemon ID name requests. Then we have this is the response schema. We are expecting all these fields out here. This is our definition of what a computer is and what are its capabilities: navigating, scrolling, drag and drop, clicking, etc. This is the config, and as you can see, this is the ID of the model that we are using. This is Gemini 2.5 computer use preview 10 2025. And then we have the agent here. This is our browser agent and its capabilities. It is able to handle actions. It is able to leverage the model responses, get the text, extract function calls, running a single iteration, and then running the. Of course, yeah, there are sometimes, safety confirmations. So the model will be asking you to whether you are okay or not with it accepting cookies and this kind of stuff. And you can build, of course, automations to automatically accept that depending on the use case on the website. And of course, here we have the agent loop, right? And this is our extraction logic here. In order to enforce the schema, what we are doing here is that we are using Gemini 2.5 Flash, and we are having a generate content config with this response schema, this Pydantic schema as the enforced schema. By the way, a very quick remark that I wanted to say: you have the possibility to use either headless mode or browser mode. So definitely, if you are building this API and containerizing it and deploying it into something like Cloud Run, you may want to deactivate let's say the browser mode and use just the headless part of it, and Gemini is going to be able to navigate the UI without you needing to really watch what it is exactly doing. Thank you for watching and hope that you enjoyed it.